Hello, hi everyone. I hope everyone's having a great day. We'll start with what we have to do today and revise everything just in a few minutes. Let's wait for people to join in. Let's give it at least 5 minutes for people to join in and then we could start. Meanwhile, what we can do is we can just be set for how it's going today, right? Did you all get the documents though, which I asked to be shared yesterday? Did you folks get the documents, the PPT, the link, and everything? Yes, we will recap. Don't worry. We'll start in a few minutes. We'll wait for 4 or 5 minutes more, and then we'll start. Just tell me if you got the documents or not yesterday. I shared the code file as well as the. It will be there in the description box below, and you can see the document link over there, all documents, and that's exactly where you'll find it. Can you see it on day 2? Should be able to see it. And am I audible? Tell me today, first of all, itself, so that you are not facing any issues. Audible or not audible? Guys, give me replies so that I know that we are good. Yes, no, we are lost. No. What is everybody doing? I'm audible. Okay. All right. Okay, let's wait for a few more folks to join in and then what we'll do is we'll start. We'll recap first what we learned yesterday and then we'll start with what we have to cover today. Okay. So, yes, all the documents will be uploaded today after the session. You guys already have got the information. So, don't worry at all. Post the session today, you all will get everything. So, yes, any doubts that you all have from yesterday's session? Anything that is unclear, anything that you were not able to solve, feel free to ask. No, no doubts. Everybody is clear with whatever we covered. Seems like it. Yes, we'll be deploying the model that we created yesterday, and we'll also be looking at the visualization part of it. So we know both of these things, right? We're going to be doing both these things to be able to enable you to do all of these things on your own independently. So this bootcamp is primarily for you guys to be able to build projects, to be able to build use cases, to build POCs on your own and deploy them on a certain platform so that they can be counted as projects. Okay. Meanwhile, yeah, let me just share my screen so that you all can even see. Just let me know once my screen is visible. Is my screen visible to everyone? Can somebody just confirm on chat? Yes, it's visible. Okay. All right. Great. We're going to be learning really good things today. So I hope you all are all excited about how to go on with this, right? Very, very important for you guys to be able to, build things because it's something which all of us will have to do on a day-to-day basis when we are out in the corporate world. I mean, if I'm in your place, also have to do the same thing, right? So yeah, we waited, and I think we have enough folks to start at least our recap, right? Because once we start with the recap, then only we'll be able to go ahead with the topics that we have to cover today, right? So yeah, welcome to Build Your First AI Model in just 3 days. And today's day three, the penultimate day, right? Where we learn about visualization and deployment and whatnot, so that you are able to use these models that you develop in a proper production setting or from even a visualization perspective, right? So that's the basic goal that we have when we are trying to work with today's things that we will be working with. Okay. But prior to that, we will do a quick recap, right? So as you can see that we covered module 4, 5 and 6, right, yesterday, where what we covered was data pre-processing and cleaning, model training and evaluation, as well as improve your predictions, right? So in data pre-processing and cleaning, what did we look at majorly? We looked at how do we, really split into train and test sets, and how we understood that we should always ensure that our data sets are split and we are not just using the training set or just the testing set, right? We should have both the sets in conjunction to be used when we are trying to train a model. And we also understood why we would, really need to do that, because if you are looking at the same data that you were trained on, say in your final exam also, the questions that you did in class, if those were the same questions which came in your final exam, then it would not test you, right? Because if you've already seen those questions, what will test you is new questions. So that's exactly what we are also trying to do with the model. It's like a small child. We are trying to teach it to be a better model, right? So in that process, what we really want to do is we want to ensure that the model is able to generalize. It's able to look at unseen data and also give us good predictions, right? So for that reason, splitting into training and testing data sets is very, very important. Then we saw how to use it via the sklearn.model selection library, right? Where we can use the train test split function directly, right? We saw this, how we should do this and why we should do this. And what should be the ratio? So when you're mentioning the test size, like if you mention test size as 20%, then the function automatically assumes that the other 80% is something which is your training set. So that is exactly what we saw yesterday, right? Now next, we also saw how to handle missing values. So if there are any NA values or NaN values which are existing in your data set, and what do? You deal with them. You replace them. Now what will you replace them with? We also thought about the concept and understood it, right? Like why we should use the mean values, or you can use the median values for numerical values, right? Like if you have marks or height or age or something, you can always replace it with the mean values, correct? Then we also saw that you can either use median or mean. Now the question that should come to your mind is, why would you use median? Because median itself is a better representative of the data and of the population that you are working with. So that's the reason why you could also use median. Okay. Now, post that, we saw something which is scaling or normalization of data, right? We did see that yesterday, right? And why did we realize that we need scaling or normalization? That is to bring down or clip down your data into a certain range. And why are we doing that? We are doing that so that all the data points that we have are in the same range. They are falling into exactly the same range. So that's the reason scaling or normalization becomes very, very essential. Now, I see questions in the chat where some people have asked me to explain the prediction part as well as the scaling part. So, scaling is something which you do before you train your model. So we saw that, right? Before we did fit, like we applied model.fit as a function, we did scaling before that, right? And then when we talk about normalization or sorry, then when we talk about predictions, what are predictions? Predictions are nothing but your target value predictions, which we are trying to do on your test data. Now, when we talk about an example which will help you to relate, so say you want to predict the weather for the next 5 days in a big city like Mumbai. Okay, when you want to do that, it is going to obviously take your historical data for the last 5, 10 years, whatever that time parameter is, into consideration, and on the basis of which it will predict the next 5 days weather, that is the temperature itself. Correct? Now, when it's doing this, what is it that it's undergoing as a process? It is using a machine learning model which will help you to predict these things which you need for your weather prediction, right? So that is exactly what is a very good example, like how for the next 5 days you don't have the data. So for your, but when you're talking about test data, you will have your data, like your y variable, which is your target variable, will be present. You will be predicting on the basis of that so that you can test whether your model is good enough or not. And then you will come across real data, which will not have the target variables into picture, right? So that's the major difference between your scaled data as well as your predicted data, like the predictions that you're making. So that's exactly what we looked at, scaling or normalization of data. Then what did we see? We saw about how to train the model and how to evaluate them. So we spoke about different metrics and we spoke about something called as a confusion matrix, right? Which are 4 different major, metrics that you can say, which is true positives, true negatives, false negatives, and so on, right? You did see that, right? Like, I mean, you did understand it with the help of an example and so on as to how those things are going to be working. So that's exactly what we want to also focus on. That is, what is accuracy, what is precision, what is recall, and what is F1. And what is the difference between each of them? I also mentioned that it's a very good trick to remember that in interviews you will be asked about this question. You will definitely be asked about the metrics and how do you evaluate your model. So you should be very well be able to answer. Now, because we've clearly tried to explain that, and you can also go over the recording multiple times. If you're not able to understand or anything is not, aligned with what you have in mind as a concept related to true positives, true negatives, false positives, and false negatives. So get that very clear in your mind before you go for any interview, because there might be questions around it. Okay. So we looked at evaluation criteria, and post that we also looked at how to improve your predictions. Say your predictions are at 70-75% accuracy. How do you improve? You use, say, your decision tree classifier. But then we also said that we would also be able to use other models, right? So we tried to use k nearest neighbors algorithm yesterday, and also we tried to use logistic regression, right? While we tried to do that, what were we getting at? We wanted to see how these models are going to perform, right, in each of the cases. Like, how would it deal with data? What kind of performance accuracy is it giving? What is it that it's helping with, and so on, right? So that's exactly what is the way to go ahead with. So if you're trying with one model and if it doesn't work out, you use the other models also which are there to check if your data is generalizing better with those models or not. So it's good if you're able to work with the other models also to improve your performance accuracy and see how it works. Okay. So then how do you compare those models using accuracy scores, right? Then one major last important concept that we saw yesterday was about overfitting and underfitting, where we said that overfitting and underfitting itself is very, very important for you to understand anything and everything related to machine learning. And we showed you some graphs, right? And those graphs itself told you that which particular model is overfitting and which is underfitting. We also defined it that, okay, whenever your training data accuracy or performance is greater than your testing data, then it is overfitting. And if your testing data is performing greater than your training data, then it is underfitting. And underfitting is basically something like it's not able to generalize really well on your overall data. Whereas for overfitting, for the test data, the predictions are not coming out very well. Basically, for your unseen data, right? Your unseen data becomes very, very important to look at, right? Because it gives you a much more wider perspective on how the data is going to be performed, right? So considering all of those things, we have looked at the most important part of, what you can say is when you are building a machine learning model. These are the most important concepts that you need to look at when you are trying to work with any AI model and building it. So all of these concepts come into very, very major existence at that point in time, right? So yes, this is what we did yesterday largely. I can see that I have covered most of the questions that are asked on the chat. For the metrics, if you want me to explain, we can take 5 minutes at the end and I can explain you the metrics part again. So if there are some questions related to it, we can still, go over it. All right. So are we good to go with today's day and look at more colorful things today? Because we are going to be looking at a little bit of visualization. Are we good? Or is there any major question that needs to be answered for whatever we've covered yesterday? If there is any, please drop that down in the chat at the moment itself so that we can move ahead and we can learn more new things which are lined up for today. Any questions that you have? Anything? I don't see any questions yet. So since I don't see any questions, I am under the opinion that you all don't have any other questions, right? Okay, okay. Okay. Is it AI model or ML model that we are deploying now? So what we are going to be deploying is a model that we created for Iris itself that we'll be deploying today to show you how it translates to an end-to-end application over the course of 3 days. So that's the basic logic behind it. For you to be able to, understand things in a much, much more simpler way and how we can enable you to build projects. Okay. So that's exactly what we would really want to, do. Now, somebody's asking about explanation about the metrics, simplification of that. So metrics is similar to, say whatever project you build. Say you are asked to build a water conservation project. Okay. Now, when you are building this water conservation project in school, maybe you were trying to implement a water harvesting technique and you built some roof. Okay. Now, say when you build this roof, it's not completely foolproof. It has some leakages. Now, when there is some leakages, 100% water will not go through the pipe and be conserved via the rainwater harvesting because there will be some leakages, right? So, in this case, the performance will not be 100%, right? There will be some problems due to which the performance will drop. So, that's exactly what we are checking via accuracy metric. That is, we are comparing the predictions that the model has made with the actual target variable that we have. So say our target variable in this case for the iris dataset was the flower species name, right? So what we have predicted is exactly what we will, try to work with and try to see that how it's going to really predict. So if it's going to predict in a similar way, then you will get close to 100% accuracy. But if the model is not able to predict in a similar way, then it will give you lesser numbers. So those lesser numbers are nothing but your performance accuracies that we are really talking about. Okay. So that's exactly what is accuracy in the most simplest form. I mean, the most layman terms that I can use is what I've tried to use over here to, explain. Now you can even rewatch today's earlier segment as well as go through yesterday's topic. Because now what we'll do is we'll move on to understanding the concepts that we are to cover today. So today is day 3, our penultimate day of the bootcamp. So today we learn about visualization as well as deployment. So the first module would be to visualize your model's performance. And the second one would be to make it real, that is deploy with some tools which I use, something like say Streamlit, Gradio. These are tools which help you to deploy these models on UI interface, basically on a website or a link on an interface which you can see, which you as an end user can use to work with. Okay, now let's move forward. So these are the topics that we'll cover when we want to visualize the model's performance. Now here, what all we'll cover? We'll be visualizing the data using libraries like Matplotlib and Seaborn. So I'm pretty sure that you might have heard about these libraries, both Matplotlib as well as Seaborn, somewhere down the line. Somewhere in Python, you may have heard about it. Right? So that's exactly what we'll use to display our graphs and charts. Now we'll be plotting the confusion matrix using sklearn.metrics plot confusion matrix as well. Then we'll be creating bar charts for model comparison. So you remember, right? Yesterday we ran multiple models and we were trying to compare its predictions, like compare its metrics. So to do that, we will be creating bar charts for that model comparison to show you how we can create these bar charts and which can be forwarded to your company personnel ahead, like maybe CEOs, CXOs, and more experts who would be wanting to see the results. Then at the end, how do you do the storytelling, like the visual storytelling, which will help us to, get to understand how to turn these numbers that you've gotten into insights. So it just does not end with, creating those charts and graphs. It goes beyond that. That is the storytelling aspect, where you are able to convey to the customer what you have really built and how you would really want to convey things, and how would you do that, the process of doing it. That process of doing that is nothing but visual storytelling. Okay. So now let's start with understanding why visualization matters. So if I give you a file which is full of numbers, it's going to be very hard to understand and interpret, right? So that is something which is very, very important. That is good visualization, because it will help you to reveal patterns. It will help the model to learn and look for nitty-gritty small things which will help you to build on, which will help you to explain things from a model perspective. So it will help you to reveal patterns, right? And then make results explainable. That is, whatever prediction the model is giving you, how did it arrive at that? The number of features it used, so the sepal length, the sepal width, petal width, how did it utilize this to make it explainable? That is what good visualizations give you as a major input. Next, it is also used to impress your stakeholders as well as your teammates and further C-level executives, that is the higher level people in your organization. And as it says, right, like a picture is worth 1,000 words, that is, a picture will tell you 1,000 stories. So that is exactly what conveys your intent in a much more easier way. Okay. So visualization matters as the end goal. Now, what are the different tools which we use in visualization in Python? The first library, the legacy library, is Matplotlib, because it is low-level library. It does not use a lot of, compute or processing or anything, and it's highly customized. So Matplotlib is the best library which has been created for plotting graphs and charts. Next comes Seaborn. Now, Seaborn is the new age Python graphical library, which helps you to do high-level plotting. So you can deal with more larger data also in a much more easier manner. So it makes things way more easier with beautiful default styles. And sklearn.metrics itself, which is a built-in model which has evaluation plots with sklearn itself. So these are some of the Python plotting libraries which you can use to visualize your graphs and charts. Okay. Now, if you want to visualize your data with Matplotlib, what kind of code you can use? First of all, you will need to use this library, which is called as Matplotlib, and you will have to import the pyplot function from within it, so that you are able to utilize this in your notebook. So now let's also do this. That is, go to our notebook and then plot these points and see what it's giving us in terms of graphs or charts. So let's do this. So before that, I'll just explain you the code. So you import this library by using this function, which is matplotlib.pyplot as PLT. Then next you go to print a scatter plot. So scatter plot will show you all the points on different parts of the graph that you are trying to plot. Here we are plotting the sepal length against the sepal width. So it will show you those points at how close the sepal length and sepal width values are. And you are naming the X label as sepal length and Y label as sepal width and the plt.title as sepal length versus sepal width. Right? So this is how you will be able to, do all of this right here. So let me just go to the notebook to show you this. So yesterday's notebook is what we can use. Okay. So let's just say import Matplotlib dot pyplot as plt. Okay. Then what we want to plot is plt dot scatter. Right? That is what we want to plot. And we say we want to plot sepal length against sepal width. Okay, we can just check what are the names of the columns here first, so that we don't make a mistake later. So it's sepal underscore length and sepal underscore width, right? So you can just go here and correct that. Sepal underscore length and sepal underscore width. Capital X. This is how you debug and get to know what are the errors. Okay. So this is how the patterns are as to how the sepal length and sepal width are plotted against each other. But now if we look at this, we don't even have the X label, the Y label or anything. So let's add some labels to it so that it becomes informative enough, right? So we can say plt dot X label, just simple length. plt dot Y label, which is sepal width. Now it has marked that this is sepal length and this is sepal width, right? And it's showing you the scatter plot, the relationship between the two variables, sepal length as well as sepal width. Now let's also give it a type. So let's just say plt dot title. Let's give it sepal length versus sepal. And now when you execute this, this is nothing but your plot, right? Sepal length versus sepal width. And this is how you complete your visualization for the Matplotlib rendering. That is, this is nothing but using your scatter plot to be able to do that, right? So it becomes way more easier. It allows you to do a lot of things. That is customization and making you do a lot more things than what you can do in a regular Excel chart or whatever. So this is how you can create one via the Matplotlib process, like just by creating a scatter plot. Okay. Everybody been able to create this? Did anybody face any issues while creating this? The scatter plot? I don't see any doubts in the chat window. So I'm assuming we are good with this. Right? Okay. So let's move on. Now we'll try to use the Seaborn library. So as I said, right, Seaborn is a much more newer version. So we'll use the Seaborn library to plot a pair plot. Okay. So you can do you can import the library by using import Seaborn as SNS. And then we'll use a pair plot. In pair plot, what will happen, you will see. So here you can give the data frame, the entire data frame only to it without separating into X and Y as features. You don't need to do that. You can just mention that the hue is species, which means that we want it to color it, like all the color that you'll have will be by the label of the species, that is Setosa, Virginica, that. So that is exactly what it will do. Now I'll just show you how it looks like. Let's go back to the code. We'll just say import Seaborn as SNS dot pair plot iris hue equals to species. Okay. It's my data frame. Second is iris. You can just mention iris here, the data frame that you have. And now when you run this, it will create a pair plot. Okay. Now what you see on the screen is one variable pitted against the other in an XY axis format. So if you see here, sepal length is plotted on the Y axis, whereas what is on the X axis, when you go down, you'll be able to see sepal length. So since there are 4 features, when you plot one against the other, you will get 4 into 4, 16 combinations. Okay? So that's why you'll be able to see 16 graphs in the pair plot, as you can see here. Right? And when you plot one against the same, right, like petal width against petal width, you will get this kind of a chart instead of a scatter plot, right? Because they will just be superimposing the same points. So in this context, you will have this chart which is showing you the petal width against petal width, wherever it's plotting the same variable against the same variable, like petal length against petal length, and the color is by the label. So you can see that since there are 3 different species, it's going to show you 3 different colors according to Setosa, Virginica. So it's able to create that kind of a mix of colors which are needed. And this kind of a chart looks way more appealing, way more, interesting for you to interpret also, because it can see color and whatnot. Right? Yes, that's what somebody has mentioned at the chat also, that pair plot seems better than doing it for individual features also. It saves time as well as line of code. That's absolutely right. So this is exactly which makes things way more easier for you to do. We can just scroll it up if somebody is not done sns.pairplot. It's very easy. So it's just one word .pairplot, and you mention the data set here, and then you mention the hue if you want. If you do not want the hue to be species, you can just ignore that part. And then say import Seaborn as SNS. Any doubts for the Seaborn implementation, guys? Any questions? Feel free to ask that on chat. If there are any, I think these are easy things to deal with. So all of you are able to cope up with this, and there are no challenges here. All right. Are there any questions, any doubts? Okay, fine. Let's move ahead then. Okay. So the visual approach will be much more better for you. You will also like it because it seems more interesting. Even I like Seaborn more. Avoid using Matplotlib as far as possible. That's what the thing is. You can use a lot more in like Seaborn itself. Like if I have to show you something, Seaborn plots, there is an interesting link which shows the overview of all the Seaborn plotting functions. So let me just show that. This is one such link. It shows you all the different plotting functions, because if we see all of them right now, then we'll not be able to, cope up with the topics that we have to cover. So I'm just showing it to you here. You can load any data set and work with the different bar charts, historical plots. These are histogram plots which have been created. This is KDE plot which has been created. There are way too many distributions. Like, I mean, you can create different types of plots here, very advanced plots as well. Box plot, all of this is new. Point plot, violin plot, strip plot, swarm plot. This is all very, very categorical itself is new as a category. This plot is also new. So all the latest graphs and charts are something that you will find on this link over here. I will add this link in my PPT so that it reaches you automatically when I share the suppose. Okay, or I can put this here also for your reference in the collab file. So I will add this to the collab file. Okay, so this is also something which you can go through, because we'll not be able to cover completely everything in detail. It's highly intensive. So you can do that at your own pace while you explore. Okay, since all of this documentation will complete eventually. Okay, fine. Now let's get back to understanding our major thing, that is how do you plot a confusion matrix, because that is a very important thing for you to be able to do, because you might have to add that to your reports or send this to your business colleagues in emails or wherever you want. I mean, that is quite possible. So that's why you should learn how to plot a confusion matrix. So here you can see that in sklearn, from sklearn.metrics, you can import your plot confusion matrix. As you can see here, there is a function that exists which helps you to do that. Then there is import matplotlib.pyplot.spld, you already know that. And there is a function which is plot confusion matrix. What it needs is the model which was used, which was trained on. Then you have your X test, your Y test, which go as inputs. Then your display labels, which is your target names, that is your target variable that you have. Then your CMAP, that is you want all the blues to be used to be able to work with this. Then normalize equals to true, that is you want to normalize all the values, then you set it to true as a flag, else you don't. So if you normalize it, it will be within the range of 0 to 1. That way. And then you'll have a plot package, this confusion matrix, and then you say plt.show. So this is nothing but your Matplotlib version of displaying a confusion matrix. So what will it show? Confusion matrix is something that we discussed yesterday, right? Which would display true positives, true negatives, false positives, false negatives, and so on, right? So it will show your model's correct versus incorrect predictions. And it can diagnose which classes are getting confused or which classes are not predicting properly, right? So now let's go to the code file and start building on our confusion matrix. Okay. So now first of all we'll have to import it, right? So we say from sklearn.metrics import plot underscore confusion underscore matrix. Plot underscore confusion underscore matrix from sklearn.metrics. Cannot import this name. This is what is used. Let me just check the documentation. So whenever you come across such errors, right, you should always check the documentation, because many a times what happens is the latest libraries have made some changes to it, because these are all continuously evolving things. There might be things which change it. So instead of plot confusion matrix, it is nothing but confusion matrix display. So I'll have to change this. So that has been changed in the latest library version that is there. So you can always visit the documentation for it. So this is the scikit-learn official documentation. You just write scikit-learn on Google, and this is the first link that you will get, and this is your official documentation which is used. So I'm just going to use the import statement as is from here because things have changed. Plot confusion matrix has been changed to confusion matrix T. And why is it that I don't remember this? Because we don't use this a lot these days, because if I have to use it, I might use Seaborn, or I may not use it directly. I may import it in an Excel and do some further analysis on it and then send it to my stakeholder. So that's the reason why you may or may not require. So it's the best thing to do is to refer to the documentation, because the documentation is something which will give you the best kind of understanding on this. Right. So let me just now create the confusion matrix. Okay. So let's just CM equals confusion matrix on my test as well as predictions. So it has done this, it has created the confusion matrix. Okay. Now this is ready. Now if I want to display it, what do I have to use? Confusion matrix display. I use DISP just as a variable. Confusion matrix display. See, it's giving me the code, that is confusion matrix equals to CM, which is the variable that you created where the confusion matrix is stored. Your display labels are your iris target names, disp.plot and plot. Okay, it's going to give me an error for target names because I have changed the iris data set to be showing me something else. So if I just load it back to this, then it will give me the target names tests. Like if you use it from sklearn datasets, then it knows what target variables to take. Now, since I have used the confusion matrix display, you can see, let me just zoom out a little bit so that you are able to see this. Okay, so this is my confusion matrix, which you can see over here. And here you can see that two labels are there, the predicted labels, and the actuals versus predicted is what is displayed over here. Now, since we have, like, you already know that we have 100% accuracy, right? We got 1 as the model score yesterday when we were looking at it. We did get a model score of 1. So while we were getting that, you can see that all of them are true positives, the ones which have been displayed here, right? You can already see that it has a model score of 1. So that's why all are true positives. Else you will see numbers even in the purple boxes, the ones which have been misclassified. The ones which have been wrongly classified are in purple, and the rest of them yellow, green, and copper yellow. All of these things are in different colors. So your true values are in different colors, whereas your misclassifications are in different colors. So this is a good way to showcase how your model is doing at a certain period of time. This gives you a good enough understanding as to how you can move ahead with respect to the model, whether you should go ahead with the same technique or should you go ahead with another. Okay. Is this clear with everybody? How to create the confusion matrix? I can just show you the code so that you are able to write it as well. Everybody understood this is the same confusion matrix that we understood about yesterday. It's just that we are learning how to display it today in a much more better, colorful way. That's exactly what we want to do. Are there any questions that you guys have? Yes or no? If there are any questions, please drop them in the chat window. Great to answer all of your questions. Or are all of you all just trying to write the code? If you all are writing. Okay, you good? Fine. Let's move ahead. So when you interpret the confusion matrix, so you looked at the confusion matrix, right? Which you can see on your screen. Now here there are some actual values and predicted values. So the actual values are in the column. So my actual values are my column here. Whereas my predicted values are my rows. Okay. Now when Setosa, like when it was actually Setosa and it was predicted as Setosa, then it's true then. When it's actually versicolor and predicted also versicolor, it's a true value. When it's actually Virginica and it has also been predicted as Virginica, it is a true value. These are nothing but your true labels. Whereas your process that you see over here are nothing but your false labels. That is, they're not your false labels, it's just that true has been marked as false or false has been marked as true. It means a girl has been classified as a boy and a boy has been classified as a girl. Or a Maruti has been classified as a Swift and a Swift has been classified as a Maruti. Something like this. That is wrong classification that we have. So this gives you a very good perspective and it clears out your entire results in a much more presentable way. That's why you can use the confusion matrix to display this to your higher level people in command, whoever you have in your organization who is on the higher level, who is, trying to look at things and so on. So target names, if it's not working, guys, try to import your from sklearn dot datasets you were importing iris, right? So from that, if you import your iris variable, then you'll be able to get the target names. Okay, you can use species specifically also, that's fine. It will work irrespective. So that's it. Okay, so this is how you interpret the confusion. So if you have any questions regarding this, drop me a message if there is anything that is unclear. Now we'll do one more visualization before we go to our next module, which is the last module. So visualizing the model accuracy in the form of a bar chart. Right? So we did look at 3 different models yesterday, like decision tree, KNN, logistic regression, and so on. See, these are the accuracies if I want. And I want to create a bar chart workflow. So I'll give it the models as well as the scores along with it. And I'll say that my y label, my y-axis is nothing but my accuracy. And my title is model accuracy compares. What will this do? This will help me to create a bar chart. Okay? So let's go to the code and let's create a bar chart. So let's first create models as well as scores. So my models equals to 3 is first, second is KNN, and third is logistic regression. Right? Now, post this, you have scores which will have the different accuracy metrics. 0.94 you got. With 3, you're getting 1. With KNN, say you got 0.95. With logistic regression, you're getting 0.9. Okay. Now, these are our 2 values, variables that we've created. Now, I want to plot it. So, I say plt.bar and I pass to it models as well as scores. Post this, what we do is we will say plt.ylabel, which is my y-axis, which is something which I will mark as accuracy. I can put an x label also. So we'll say model and plt.title as model accuracy. Now when I execute this, it's going to show me the bar chart. It's exactly showing it to me in the way that I would want to see it. That is, it has all the variables plotted and it has all the accuracies also very clearly showing the difference between the accuracies, which you would also expect to be in certain way, right? Like you are able to see it. So that's what you would also want to see. So this is exactly what is happening over here, that is you are able to see the model accuracies as you would wish to see. Correct? Any doubts still here? If you have understood how to create this bar chart, I will show them. Yeah. Can you see the code now? You should be able to create this. I'll give you 30 seconds to copy the code and to be able to create it. If anybody has any questions, then let me know, because we are pretty much at the end of the visualization module. We'll go to the deployment module next, but just so that if you have any questions, we can clear that out right here. We have a few slides to go before that, but from code perspective, if you all have any questions and if you've not understood anything, please do ask me. Free to interrupt me at any point of time as well. Keep spamming the chat window with all your questions so that everything is answered and you go home with a clear mind. The most important and the most interesting stage is going to come now, which is deployment. So that is very, very interesting. Without that, it's not displaying. Okay. You can change the colors of the bars and a lot more. There are so many capabilities that the bar chart also has. There is a lot of documentation around it as well. How you can do that is you can always check that in the documentation. So it gives you ways to colors. There is a parameter which is called as colors. So here if you mention color. When you mention color, what color do you want it to be? You can always, set it accordingly. So color could be, blue, red, green, whatever you want. And on the basis of which you can create those charts. So now the bar chart is ready. So as you can see, you can directly just modify this in any form that you want. Why is this happening? I just mentioned the color over here. Since I mentioned the color as red in proper strings, that is why the color is changing. If there is anything specific that you have as a question, then tell me what is happening. No, it's all three bars are of the same color. If you want three different colors, let's try that. But we'll not be able to spend a lot of time in this. So yes, if you want all the three bars with three different colors, very appealing to everybody, then yeah, you can try this as well. It can create different colors according to your requirement. So that is also possible. It can help you do that with the color parameter. Okay, I think let's now go back to the slides. Okay. So some styling tips for your clean chart. So what you can always do is add some titles, some labels and legends so that it's readable. And then what you can do is use consistent color themes. The same kind of color theme can be used across your presentation, across your PDF, however it might. I mean, you can do that. Then you can label your axis also clearly that, okay, this is my x-axis, this is my y-axis. But please don't clutter charts. Make sure that you don't clutter your charts. You don't add in a lot of information. You don't throng it. That is something that we don't do. Highlight key insights with annotations. So you can, just annotate different parts of the graphs and charts also so that you can give in more information. These are just some beautification and styling tips for your charts. You can just keep this in mind while you are creating charts. Now, one last thing, that is visual storytelling, just turning your numbers into insights. So your raw metrics, which are dumped into a console, like something that you see as a part of the Jupyter Notebook output, is not a good way to present your results. What you can have instead is you can have a bar chart with annotations. And unlabeled scatter plot is not useful. If you have access, legends, and titles, you have a labeled plot, it will make more sense. And if you have an overly complex chart where you have 10 different colors, where you have 10 different values being shown, and it's not giving clear idea, that is not the right way to create visualizations. You should have clean, focused insights. And you should also focus on the fact that what is it that the viewer should take away from this conversation, like the presentation that you're having. What the viewer should remember and take back is something which is very, very important for you as well from that perspective. Okay. So yes, that was about visualization. I hope all of you all are ready to now go to the next module, which is about making it real. That is, this model and all we created, all of that is fine. Now, how do you make it real? How do we deploy this with more easier mechanisms? So I don't know how many of you have either used like Streamlit, Gradio, or Flask, or Django, or APIs, or I don't know how many of you have done all of this, but those are mechanisms through which you can deploy your code. So we'll see some simple things to see as to how we can deploy this particular model that we've created for the Iris dataset on a UI interface which is usable. So we'll see these four major points, that is introduction to Streamlit or Gradio, which is a fast UI for ML projects. Then we go to writing a simple Gradio app to take inputs and show prediction. Then what we do is add a title or a form or output text. All of those things you will add to your screen. And then next what you do is you will publish your app on Gradio so that anybody can actually use it. Right? That is something which is what you do when you try to deploy your model on Streamlit or Gradio or such similar applications. Yes. So if some of you have used Flask or Gradio or Streamlit, it's great. It's a good experience to have. That is, you can do things like this, right? To be able to work on. Now let's move to understanding why deployment actually matters. Deployment matters a lot, right? So what does deployment help you do? So deployment is nothing but including your training, testing, and then exposing this interface to your commoners, that is your users. So from training perspective, models will learn patterns from your label data, right? And testing will be evaluation of your models on unseen data. So it ensures that the model is not just rote learning. Like all of us in school would have done some form of rote learning here and there, right? That is something which it's asking you to avoid. That is, it's ensuring that the model isn't just memorized. So you train on your past data, but you test on your future like data. That is why deployment is very, very important and very, very essential. Now, what is Streamlit? Streamlit is nothing but a Python framework which turns scripts into web apps. So it helps you to do this. So you have like a Python script, it turns it into a web application. And it's great for ML, data science, as well as data. And you don't need any knowledge of HTML or JavaScript or CSS. Just the Python code, write it into a file which is called as an app.py file, app.py file. We will see that. And then you just run the app and it works. That is exactly what is deployment using Streamlit. Very, very easy. Now let's look at what is Gradio. So Gradio is also a Python library which turns your ML models into interactive web apps. Okay. So when you say interactive web apps, you can actually interact with it. That is, you can add in certain form inputs and you will get certain outputs related to it. And why do we choose Gradio a lot more? Because it works directly in Google Colab or even Jupyter Notebook or even locally. And of course, you don't need any HTML, CSS or JavaScript, just Python is what you need, right? So that is the same, that does not change. And the key features are that it has a very simple interface for input as well as output. And it supports like text as well as images, as well as numbers, as well as audio, whatever you give it as an input. And then what it does is, it automatically creates a shareable link. So when it creates a shareable link, when you click on it, it creates an interface and you can fill in the details and get your predictions right there. So this is one advantage that you have with respect to Gradio, which you may not have when you're working with Streamlit. So that is an advantage which you can work with. And it becomes very, very easy to work with Google Colab, because a lot of us tend to use Google Colab, right? Because it's very easy to work with. So that's why Gradio is very, very user friendly and very, very useful. Now, how do you work with Gradio? So if you have to work with that, what do you do in Google Colab is you install it. So you say pip install Gradio. Okay, just one line and it will work instantly in Colab. It's compatible with your Jupyter notebooks and you can do quick testing as well as demos. Now, for such a bootcamp where we are trying to, demo and showcase a live product for you or a live working product for you, it's very easy to use Gradio because it is something which gets integrated in Google Colab. Now, I'll tell you what is the problem with Streamlit. So, Streamlit does not work directly with Colab. For Streamlit, you have prerequisites. That is, you need to have Anaconda, that is, you need to have either Jupyter Notebook or PyCharm or VS Code or something installed on your system. And the installation setup can take up to an hour at times because Anaconda as a distribution itself is very large in size. So you will need time for it to be set up. And Streamlit will work only with the local case. Or in the cloud perspective, you will have to link your GitHub account to your Streamlit to be able to deploy it on Streamlit 3. Now, the most easiest way to get your model to work is by using Gradio. So that's why what we are trying to use over here is Gradio, because it becomes way more easier and all of you will be able to see the output, see the screen very easily in front of you right there. I mean, you will not have to make any additional installs or anything out there, right? So now what we will do over here is that you will create an input form. So for that, since we have installed Gradio, right, by doing pip install Gradio, we will look at the code perspective. Right now, I'm just explaining you the concept, and then we'll go to the code and then just look at the code one after the other. And then we'll solve all the doubts that come to you because there will be a lot of doubts that will come. So you create an interface, a gr.interface that you see over here. And the function that we'll be using is predict iris. So we'll be using that predict iris function, and the inputs are sepal length, sepal width, petal length, and petal width. So it will create 4 input boxes which will take these 4 different inputs here, and then you will have an output, which is a markdown, and where the title is nothing but iris flower classifier, and the description, that whatever description you want to add. So the description that we have added here is enter flower measurements to predict its species using a decision tree model. And the theme is soft, that is, you want soft numbers, you don't want really tough numbers. So this is how you can create an input form which will take in data, consider in data, and that's how it will work. Okay. So this is how you should actually work with a Gradio interface. So you create a form and then you just deploy it. Now, to be able to do that, prior to that, we've already trained the model in the past 2 days, right? What I want you to do later is to be able to load and use your model. So to be able to do that, what you need to do is import pickle, which is a library, which will help you to store the model weights in a pickle format. So pickle.load will help you to open that pickle model which you have saved, and then you can use predictions with that model and then create the predicted class, that is the predictions that you're getting. And then you will save that model using pickle or joblib. And then you will predict on live user. So all of this may just go a little bouncer to you right now. When you see the code, you will get complete clarity on how the code is working. So we need to store our models in pickle format to be able to work with it. Okay. Now this is how our app is going to look like. This is a link on which you'll be able to see this app. So we had set the title to be iris flower classifier, right? And then we'd entered a certain description. So this description is visible here. Enter flower measurements to predict its species using a decision tree model. Then you have these 4 input variables, which is sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. Once you have entered certain values over here and you click on submit, you will be able to see predicted species as setosa over here on the right hand side. Okay, you can see this. So this is exactly how it will work. And it will give you the prediction over here on the right hand side. This is the interface that it will create on its own. Now in this, what is your benefit? Your benefit is that you don't know HTML, CSS, JavaScript. Still, you are able to deploy this and create a website without any additional library knowledge or anything that you would need from that perspective, right? So it gives you a undue advantage, which helps you to create all of these things directly without any dependency on any external library knowledge or any external new things that you might need to learn, right? So this is exactly the entire app that will be built. Okay. Now let me just go to the code and show you how we can do this. Let me just reconnect. Is my I think my screen is visible, right? So let's look at the code now. So now what I'm doing is I'm starting with a fresh file over here so that we don't overlap on any variables or anything that we are trying to work on over there. Okay. So first things first, that is we will install the libraries, that is scikit-learn and Gradio if it's not installed. So you can use pip install to do that. Post which we train our model. So import pandas as PD from sklearn.datasets, import load iris, import decision tree classifier, and import pickle. All of this is something that we saw in the 2 days that we spent on this particular dataset yesterday and day before. So iris equals to load iris, then you have x equals to iris.data, y equals to iris.target. You have model where you've initialized your decision tree classifier model and the model.fit. Now, after the model has been trained, we want to save them, right? So if we want to save the model, what we will do is just comment this and we'll just keep this with open. And you just mention the file name here. So the pickle file name that you want is iris_model.pickle. And you mention that you want to write over here, like you want to open it in the write mode or not, and as here. And then what you do is you do pickle.dump and then you mention model and the file. So in this file, you want to dump this particular model over here. So pickle.dump. So this is how you will be able to train your model as well as save the model when you execute this entire cell. You already have this cell in your file. You have created all of this. This is nothing new. The only thing that is new is this. That is saving your model weights. And this syntax is also a similar syntax to how you would save things in a file via Python code. So that is exactly the same syntax that you use over here. So with open and then the file, whatever file name you are able to, you want to write over here. So you'll be able to see post this that since this step has executed, I can see that the step has completely executed. I can see a file created over here in my file section, iris_model.pick. So is everybody done till here? Are we good till here, everyone? If you're not good, if you are still writing the code or something, let me know. I will wait because I want everybody to deploy this model so that they are able to learn. You may not even need to pip install. You are unable to understand what you have to do. What you have to do is you just have to save the pickle file. The model weights that you have, right? You just save it in pickle file. That is what you need to do. Yes, I am waiting. I'm giving you a minute, 2 minutes for this. Yes, you have to write this code. I know. It's not fresh. This code is the same that you've used in your last file as well. It's not. You can just save the file. I mean, save the model weights. It is in block format. That is okay. Just so that I can show you everything together, I have kept it here. I need to show you together, right? So that you are able to understand. As you will not be able to understand if I show it to you separately. you can skip writing this. I mean, you can just save the model weights. That will also be enough. Let me know once you start. Because once you are done with this, then we'll move with the next step. Should I wait? Should I move forward? Yes, this code is dependent. Now please repeat the process once again. So this is your model training which you did yesterday, right? You did this model fit and all of this. You've done all of this. Only thing that you've not done is saving the model. So now I will move forward. You can then look at the code. Since we have limited time to complete the bootcamp as well, I will need to move forward. You can look at the code which we will share later if you are not able to catch up. So right now just pay attention. So we've defined the target name also. Now comes your Gradio code. So what you need to do with respect to the Gradio code. So now I will answer all the questions after I have deployed this so that we are not having any breaks in the middle. I want you to understand this clearly. So you have imported Gradio as gr. Next, what you're doing is you're defining this function which is called as predict_iris. Okay, and it will take in 4 parameters: sepal length, sepal width, petal length, petal width. Where your input data is your sepal length, sepal width, petal length, petal width. And for your prediction, what you will do is model.predict, and what you will pass to it is the input data, and you will pass to it 0 because you want to pass the first row. So that's why you're going to pass the 0th index of the input data to the prediction. And then what is to be returned is predicted species, and then the prediction, whatever the prediction has come out to be. From target names, just map it to the prediction, and it's just capitalized. So it's nothing but it's presented not in a lowercase format but in a capitalized format. The prediction is mapped to the target names because the prediction may be a number. So as you know, right, machine learning models give outputs in terms of numbers. So these numbers which it will give, like the labeling that we done, right, 0, 1 and 2, which it will automatically do inside, it will map that to the target names. And this is what the function is all about. Now we'll use the gr.interface, which is nothing but your gradio.interface, to define how my UI is going to look like. Okay, so here the function that I'm going to use is predict_iris, which has already been defined. Then we are going to have 4 input values. One is sepal length, second is sepal width, third is petal length, and petal. We'll have all of these 4 input values. And once these 4 input values are taken in, we'll be giving it the title, the description, and the theme, what we discussed earlier. And the outputs are to be presented in a markdown. So markdown is nothing but it will move the content a little bit below, and you'll be able to see the markdown where it will print the output. This is the predicted species. This is your output, right? So that is what it will print over there. So once you've defined this interface, what it will do is iface.launch. So when you say iface.launch, it's going to give me this content below my Gradio block of code that you can see over here. So it says that it looks like you're running Gradio on a hosted Jupyter notebook. So for the Gradio app to work, sharing must be enabled. You need to ensure that it's shared. If you're running on public URL, it will give you this public URL, which when you click on it, it will display something like what I'll show you later. And this is the interface that you'll be able to see. Now I'm just going to go to this link, the public link which is mentioned here. I'm going to go here and I'll show you how it looks like in terms of the interface. So this is a new link which you will see over here. This new link is going to redirect me to this entire UI which has been created by Gradio on its own. You didn't have to feed it in anything. What did you have to feed it in? You have to feed it in the input text to it. Like what is the input that will be required over there? That is something which you'll have to feed it in. And you'll have to feed it in the title, the description, and how my predicted value is going to look like. So let me run this in real time. Say I will just make this 0.3. And if I submit this, it's going to give me a predicted species as Setosa. So these values which I have for sepal length, sepal width, petal length and petal width are going to give me a result which is going to be something which is clearly close to the setosa flower species. So if I change this, say I make this 5.4, 3.2, 3 and 0. It is still setosa. Now say I make this 1.2. It's still setosa, so the parameters are similar to setosa. Say petal length is still setosa, 1.2, sepal width 0. Okay, so we will need to look at what are the parameters for the other flowers to be able to get that predictions. So you can study that in detail as to what the data values will be and what you can feed it in by looking at it. And that's what you will get as the predicted species over here. Now, as everybody, yes, the model is overfitting, which is most likely the case because what we are using over here is the decision tree classifier model, right? And the decision tree classifier model in general, we do not use in the industry in production level deployments. Why? Because it is something which will always overfit. We tend to use a much more advanced tree classifier, that is, we either use random forest classifier or we use XGBoost classifier or we use gradient boosting because it is able to create multiple trees and it will not lead to overfitting. So since that is something which we can avoid, what we do is we use these other tree-based classifier methods to be able to show you, like to be able to get balanced predictions. Else we do not get balanced predictions. So that's the problem. Akash, what is confusing for you? Can you list down completely what is the issue that is causing you confusion? Bagging with decision tree is also not used in the industry much. I'll be very, very clear. They don't use decision tree in production level deployments. They might use it in a POC. In a small experiment, they might use it, but they don't use it in production level cases. I see that somebody has said that Gradio link will expire in 1 week, right? And how can we maintain code for at least a year? So if you want to maintain a project for a year, you will not use Gradio. You can use Streamlit, you can use Flask, Django, or maybe you can host it on a free tier of cloud. So say you can use AWS or you can use GCP cloud mechanisms to be able to deploy it so that they will stay, like the model will stay as is for a longer period of time. So you want to see the code back. I didn't do anything. All of this is something which came in automatically. So when you import Gradio and you define this function, which is called as predict iris, and you mention the interface, and then you say iface.launch. That is where it knows that, okay, now is the time to create the public shareable link. So it has created this public shareable link as you can see on my screen. And when I click on this, it's going to take me to that UI which you can see. That is exactly what it does. It may not work for you. There might be some syntax error or something which is amiss. So when you get this notebook today, post the class, you can check what was missing and you can fill in those gaps and you will be able to make that work. Because right now, even I don't know what is the error. Until and unless you show me what is the error or tell me what is the error, I will not be able to, work with it. Right? So that's exactly the reason why I would say that how did I get all of this in one block? I typed it. All of this is typed in one block and this comes in as an output directly when you execute this Gradio code. If that is what you are asking for. So that is what will help you to get this interface that you just saw right now, this one. And you can play around with the numbers and see what predicted species are you getting. You can even change the model. If you want to change the model, what will you do? On this particular pickle file. So the pickle file that you have, right? You'll have to save the other modules pickle file here, say KNN or logistic regression or anything like that. Okay, so you can get all of this information directly changed with the model that you pick. So if you pick, say, logistic regression or the KNN model, you will get the predictions for it on the UI that you really want to see. So that is possible. So this is something which you can do, like wonders which can be done with UI. Now, the code and all is something which I have explained. I just have 2 more slides to explain certain things to you. So let me explain that and then I will take all the questions. Last 5 to 7 minutes will only be questions for you guys to answer since we are going to be at the end of the bootcamp. So now you can style your app as mentioned, right? You can mention the title. That is, you will add a bold app title for your Gradio app that you're creating. You can mention a description, a subtitle, or soft instructions so that the people who are using it understand it very well. Next, theme. You can change the overall color plus the UI. So we've given it a soft theme. Right? So you can change the color, etc. also accordingly. Related to how you would want to display the things on the UI itself. Then you can mention article, which is nothing but a detailed text, instructions, or context. So you can mention about the iris data a lot more in detail in the article section. Then you can also have custom styling by mentioning CSS if you are really very interested in CSS and want to know about it. Okay, that is how you style the app. Now deploy to Gradio, you understood like how would you run the app in Collab locally? You would say gr.interface.launch. And in Google Collab, it creates a public shareable link automatically, right? And if you want to share your app with somebody, I can just share that URL with anybody and you can be able to test it. So anyone can test your model without installing anything at all. But since somebody also mentioned that I want to keep it for a year or so on, you can host it permanently. Use Hugging Face spaces, which are free, or host it on your own server. Just push your Python and model files to a GitHub repo and connect it to Hugging Face spaces. And that will keep your model alive and running, which you can use as a link, which you can share with anybody else, which can be further on used further for your projects and to be showcased on your resume. So this is how you can deploy your model via Gradio. Now, this is just one of the last slides which I want to cover, that is, what is the difference between Streamlit as well as Gradio? So Gradio is good for small ML demos, quick prototypes. So since I wanted to show this today over here, it's a quick prototype that I was able to create, right? Without any errors, without any debug. So that for that Gradio is useful, but if you want interactive ML dashboards, Streamlit is good. Now for setup, both require pip install and a library name. That's it. It works in Collab, so Gradio works, but Streamlit does not work. For UI customization, Gradio has limited but very clean themes. Whereas in Streamlit, you can customize your layout very well. Shareability, you can share it very easily with Collab. If you want to share the Streamlit app that you create, you will have to share it via Streamlit Cloud. And ease of use, it's very beginner friendly. Like Gradio is extremely beginner friendly. Whereas Streamlit is beginner to intermediate. It might require some coding knowledge as to how to work with the Streamlit library itself. Then you have input types, that is, you can work with different input types for Gradio, that is images, audio, text, etc. Whereas with Streamlit, you have more layout control. You can work more with the boundaries and so on, and how you would want to display your text, your colors, and so on. For deployment options, you have Streamlit Cloud for Streamlit and local hosting. Whereas for Gradio, you have Gradio Share and your Hugging spaces. So you can choose the right deployment tool according to your needs. So depending on your needs, how you would want your code to be displayed, how you would want things to be displayed further, you can always, choose your deployment option accordingly. And yes, that's it. That typically brings us to the end of the bootcamp, where now I am open to taking any questions that you folks have. It could be anything and everything. So yes, please shoot your questions in the chat. I'd be happy to answer a lot of them, even if they are stupid. Please ask me those questions so that I can answer all. You get an industry perspective, which you might be wanting to ask. You can import this iris data. Yes, you've been asking this question a number of times. You've shown this, right? Did you attend day one? You can import that iris data via two methods, and we've shown that on day one. So you can go through that content and you will get your answer. Any questions? Anybody else? I'll be sharing all the content. I've already shared content in yesterday. I'll be sharing in content for today as well. So you folks have any questions right now? You can import the iris dataset from sklearn.datasets, which you used earlier. You can use it from SNS also. There are multiple libraries which give you the certificates itself. The dataset itself, sorry. The next question is, how can I get certificate? Certificate is something which the LetsUpgrade team will provide to you. It will be communicated to you via the right channel and you will get that. Now, if you are getting an error, you can just check that with my code once it's shared with you, because I cannot see what error you're getting. If you can write down what error it's giving, it will be way more easier. Google Colab is an open source network. Likely, can you share any other network like Colab? Colab is the only free resource that we have available for executing any kind of ML, AI work. That is the most easiest way to work with. So you can use Colab on a day-to-day basis. It will be shared with you by the LetsUpgrade team very soon. Next, I think what the question is about the metrics overview. With respect to metrics, I did explain about accuracy, right? Like in terms of how you can see with respect to the rain harvesting example. Like if there are leaks, you will be losing out on the performance of your entire water, right? You won't have 100% water conservation. Then in the same way, you will be losing out on information and results if you do not evaluate the model, and if you see that the model is working very good with your regular generalized data, it may not work very well with your unseen data. So that is another challenge which you might face. Then I can see which is where you will need your accuracy as a metric to evaluate that. With respect to precision and recall, we discussed yesterday about the cancer example. So maybe you can go over yesterday's class again to see how you can answer that question for precision as well as recall. Whereas when we talk about F1 score, we did mention that that is the balance between precision as well as recall. So you might take that as the most safest metric when you would want to evaluate it. Right? So metrics is something that I have covered 3 times at least now. So I think there should be something which will be answered to you when you look at the video again and listen to it again. You can refer to some content which is available online as well, and when you look at the PPTs also, it will get clear to you as to what these different metrics are. So you can experiment with this UI interface that you can see. You can put in different data points and check. You will get those different classes. I mean, you'll have to look at the data and see what does Virginica really point to, and what the other classes are also pointing. So for Setosa, it's a different thing. For Virginica, it will be a different thing, and so on. For each and every species, it will have a different point range, and if you have the values in that range, you will get the respective flower species allocated to it. Guys, any other questions that you have? It will be shared with you in the description window of the video link where all docs are present. There will be all resources from 3 days shared with you over there. So you don't have to worry about where will you get the resources from. So let me know now, since we are almost at closure, if you have any questions. I'd like to take any random questions also that you might have from this space. So please feel free to ask anything that comes to your mind. As you shown code today, last need any import. So the imports are also mentioned in the code. Uh, I think you can go through the code to, get complete clarity on what we are trying to convey. And yes, you already know how to really now build a model. So I want all of you to really build a model on similar lines and deploy it on Streamlit or Gradio and post about it on LinkedIn so that people come to know what you are working on and what are the kind of problem statements that should be out there in the industry, which will get you really good jobs and really good opportunities ahead to work on. So that would be the best way to move forward. I would recommend you to not forget just doing this bootcamp. Post this, I want you to do more projects, which will be something which can be deployed on Streamlit or Gradio, and that's how you can work. Yes, if you want to tag me, you go ahead and tag me. I don't have an issue with that. No problem at all. But please keep creating projects. That is the best takeaway for you, right? So you can just work in that fashion if you want to. And don't hesitate in terms of experimenting and learning. Learn with new data sets, work with that, and it will just help you to do it. Documentation link will be coming in, don't worry. It will have all the details that you need soon. So don't worry about that. Yes, these notes will be provided for you. Is job better or freelancing in field of UI UX design, digital marketing or web development? Either, whatever works for you. Some things might work for you and some things may not work for somebody else. So keep exploring both the routes, whatever works for you, stick to it and then work to it. Freelancing is also good. Even a job in that particular sector should also be fine. So that's not a problem. All right. So don't worry. All the collab notebooks will be shared with you. All the PPTs will be shared with you. All right. Okay. I don't see any other questions pending from my side. So yes, thank you everybody. I hope that you all will join for the future sessions as well. There's just one question: does the data science still have freelancing jobs? Say I have. It does in a lot of aspects. It does. There is no stopping to that. So yeah, don't worry about it. You have loads of opportunities ahead as far as you're working in the right direction. You are on the right track. So yes, we'll see you in future sessions, building in more. Till then, keep learning, keep growing. Thank you all for joining. Thanks a lot, and I hope that you do well. Thank you.